What we're doing, guys, is going through volume. I'll be honest, this isn't my favorite lesson with these guys, with the way they've broken it down, but a lot of it is actually pretty decent. So let's look at a few pieces. Our learning goals for today. Determine volume of right rectangular prisms with fractional edge lengths using unit cubes with unit fractional dimensions. This is the part I'm not real big on, guys, but this is a very common testing question with our new curriculum. So you're going to have to understand it and be able to do it. Determine the number of cubes with the unit fractional dimensions that have the same volume. CJ, please stop. I'm trying to talk and we're being recorded. Okay, determine the number of unit cubes with unit fractional dimensions that can pack a right rectangular with fractional edges. And connect our two volume formulas. We're going to have two formulas we're going to use.
That's nice.
Volume is length width height, or a capital B times H. Which actually gets to a couple questions I had in a previous lesson. I'm not sure if I got a recording on this one, so I do want to hit it again. The question I was asked, why do we use a cursive L for our formula for like rectangles and volume? What do you think, Wyatt?
So it doesn't look like a 1.
Excellent. So it doesn't look like a 1. Then the counter that the student had was, well, if it's going to look like a 1, why not use a capital L? What do you think? Excellent. Capital and lowercase mean different things. So for example, we've had our triangle formula. We say A equals 1/2 BH, correct? But now we see a capital B. Is that different?
Mm-hmm.
Yes. B is my base side of a figure. A capital B is the area of the base. So it has different definitions. So that's, again, getting back to our vocabulary and the importance of understanding what it is. It is a major difference. So we already worked together to determine each least common multiple. That's all we got to do. Guys, if you're using cake, this should be easy. And you should have been able to find GCF as well. Did you say that one? Okay. If you didn't, no big deal because you weren't told to, but you should be able to. 2 and 10, which goes into both? 2. Gives me a 1 and a 5. So I'm at a 1. I know my GCF is 2. My LCM, 2 times 1 is 2 times 5 is 10. 3 and 8. I can divide both those by
2.
Can't do 3 by 2. 1. So we had a special math term for that. Who remembers what the special math term was? Awesome. Well done. Those were relatively prime. My GCF is 1. That means relatively prime. So to find my LCM, I multiply the numbers, which gives me 24. 6 and 14. I can divide both those by 2. Gives me a 3 and a 7. So GCF of 2. LCM is 6 times 7 or 42. Yes? Question or just stretching? Stretching? Okay. 10, 15. I can divide both those by 5. Gives me a 2 and a 3. So a GCF of 5. LCM of 30. Questions? Are these becoming easier? Do you guys understand how to do these? Who's still struggling? Please be honest. A little bit? Okay. Those of you who are struggling should probably come into the seminar for a little extra help, okay? Our first problem today is a thinking problem. I actually have high hopes that someone in here will get it. Someone named Richard, because this is a great task for him. You have 2 empty containers, each with a different volume as shown. You also have a source of water. Here is your task. Using just these containers, you don't have any other tools. You don't have spoons or measuring cups, nothing else. All you have is these 2 containers and an endless source of water. How can you measure out a volume of exactly 4 gallons? So we're going to let you talk about this as a table. We'll give you 3 minutes to talk through it. See if you can figure out, using just a 3 and a 5 gallon container, it has to be exactly 4 gallons. Okay? You have 3 minutes. Go. Okay, guys, let's start our discussion. Who thinks they came up with a way to get exactly 4 gallons? Jamal?
5
my a gallon into the 3 gallon.
But how do you know exactly how much a gallon is? You don't have any other tools than these two buckets. How, CJ? Okay, so mathematically, although you're actually incorrect on that, because you'll see volume is basically, it's not exactly exponential, but volume gets big, really big, really quick, because I'm multiplying 3 different numbers. Ainsley? See the problem on that one?
Yeah.
I had great hopes because you initially were kind of on the right track. Gabby? How do you know exactly when you've drunk a gallon of it, though? No, you don't. There's a way to do this. I'm going to show you how if nobody can get it.
So you fill up the 5 gallon bucket once and then pour out 4 gallons.
How do you know exactly 4 gallons? All I've got is a 3 and a 5.
So make sure you do 4 gallons.
Guys, one at a time. Please don't talk unless I'm called on you.
2 gallon bucket, dump that out, and then add 2 more.
Again, I can't. How do I know exactly 2? Yes.
Fetch 9 gallons with the 3 gallon bucket and dump out 5 gallons with the 5 gallon.
How am I going to hold 9 gallons? My biggest container's 5.
We only have 1 3 gallon.
I only have 1 of each. Believe it or not, you're like the closest so far. You're on the right track. Augusta? How do you know exactly 2 gallons? Storm? Okay, so mathematically you're on the right track, but unfortunately this is a real world problem. In real world, having the number doesn't give me that measurement.
Both the gallons equal 8 gallons, so maybe if you try pouring out half from each, you could get 4.
But again, how do I know exactly what half is? Because these are actually not straight, so I can't even really judge it. But even then, I need an exact measure of 4 gallons. And in both cases, now you're guessing twice where half of each is. Okay, looks like we've hit a wall. Miliani? No, all you have is these 2 buckets. Gigi? Okay. It's okay. Guys, here's the deal. Watch. Watch and be marveled. Okay, what I'm going to do, I'm going to fill the 3 gallon. You guys should be writing this down. Pour it into the 5 gallons.
Everyone's pencil should be moving.
That's actually important because I now know I have exactly 3 gallons in the bucket, yes? Okay? Then I'm going to fill the 3 gallon. But now I can tell exactly when I've poured out 2, can't I? Okay? Because I'm going to pour 2 gallons into the 5. So I've now got exactly 5 gallons in the 5 gallon bucket, yes? How much is left in my 3 gallon bucket? 1. So what I have to do now, because I've only got these 2, empty the 5 gallon bucket. One key on this was you had an infinite water source. May not have seemed important at the time, but it's actually what makes it possible. Empty the 5 gallon bucket. Pour the 1 gallon in. Got it. Fill the 3 gallon and put it in the 5. So how much do I have in there now? Exactly 4 gallons.
Wait, really? How do you know how much a gallon is in the 3-gallon bucket?
Because he poured it.
Because I poured exactly 2 into the 5. Because as soon as the 5 starts to overfill, I know I've done 2 gallons, yes? So if I pour 2 gallons out, how much is left in my 3-gallon? Make sense? So do you guys see the process? Okay. This is actually a really important thought activity to help you understand the concept of volume. Volume is how much is inside of the buckets. To get to exactly 4, we wasted a lot of water, but we were able to get our exact measure of 4 just using the 3 and the 5. Does everybody understand your process, the thoughts that go into it? Okay? So now that we've done that, let's actually turn the page. We'll start looking at it. We do need a lot of highlighter today. So pull out your highlighters or marking pens. If you don't have them, again, the student desk is always a good option. As a quick side note, for those of you who have still not finished your Topic 2 vocab sheet, almost half of your answers are on this page. If you haven't done it, you can pull it out. Yeah? Okay, guys. We're going to start with a geometric solid. A geometric solid is a bounded, 3-dimensional geometric figure. In other words, it's saying I have sides that aren't movable. A polyhedron is a 3-dimensional solid figure made up of polygons. In other words, my sides are a shape that I know. A face is one of the polygons that makes up a polyhedron. In other words, when I look at the sides, it'll tell me what that shape is. An edge is the intersection of 2 faces of a 3-dimensional figure. And then our last part on this is the vertex, which is the point where multiple edges meet. Now, with our new curriculum, this next one is actually a very important term. It is a unit cube. They really like this. Most of the testing that you're going to see based on this, they go to unit cubes time and time again, which makes sense because it actually tests several different concepts. But a unit cube is a cube whose sides are all 1 unit long. We also have 2 special types of 3-dimensional figures that we're going to use a lot of, especially in this section. The first is a right rectangular prism. This is a polyhedron with 3 pairs of congruent and parallel rectangular faces. In other words, all the faces are rectangles. Our second one is a specialized right rectangular prism that you guys probably already know. It's called a cube. A polyhedron that has congruent squares as its faces. Okay? So there are basic definitions. Everybody should have those highlighted, right, Richard? Highlighted in your book. I do want to add just a little bit onto the figure to help give you some additional information. They did a nice job of showing us the faces, but they didn't talk about edges and vertexes. So edges are these pieces. This is an edge. It's where 2 faces meet. Okay? This would also be an edge. Make sense? This point right here, where all 3 of them meet, that is our vertex. Okay? So the vertexes are basically right at the extreme edges where all 3 surfaces meet. It comes down to a single point. So the edges are aligned, the face is the whole shape, and the vertexes are points. Questions on any of this vocabulary? Because you guys have to understand the vocabulary. If we're asking you what the face is and you tell me about an edge or a vertex, did you answer the question? No. So we need to make sure we understand those. Okay. Go moving on. Number 1. How can you determine the volume of the tank? Does anybody know what the volume formula is offhand? We gave it to you, Keegan?
Length with height.
Good. So volume equals length times width times height. Now, just as we did with area, one of the first things we're going to ask you is write down your basic formula and then label it on your figure. Okay? So what is my length in the figure? Yeah. That's okay. You can still say it. 50? Okay. What's the width in my figure? Storm? 25? So we're saying the height is 30. Honestly, that's the way I would have done it myself. Side note, does it really matter?
No.
No, because I'm multiplying, which property says because I'm multiplying I can do it in any order? Vivian? Thank you for saying it all properly, commutative property of multiplication. Guys, if you have written the base formula and you've labeled your figure, the next step should be super easy. Literally, all I'm doing is putting it into the formula. So how many cubic inches of water can it hold? I go over my base formula. What did I say my length was? 50. I said my width was 25. I said my height was 30. Guys, this right here is half credit. If you make a math error after this, as long as you don't mess up the units, you're going to be okay. So now I get to choose my math order, commutative property of multiplication. Mr. Moore is going to say, oh, I love doing zeros. So I'm going to do 50 times 30 first. That gives me 1,500. 3 times 5 is 15. 2 zeros, 1,500. I have one number left, 25. So 2 zeros, 25. 2 gives me 7,500. 2 zeros, then a third figure I'm in the tenths place. 2 times 5 is 10. 1, 0, 0, 5, 7, 3. So 37,500. Guys, my units are always going to be cubed in volume because I've got 3 units that I am multiplying by each other. Remember, that means inches cubed just means inches times inches times inches. This is just shorthand, so I don't have to write all of that out. Make sense? CJ? You look a little confused. Does it make sense? Look at it. I did 50 inches, right? Times 25 inches times 30 inches. Inches times inches times inches. I write it as inches to the third power. Gabby? Not really, because we got half an hour left and I got like 3 pages to get through. Okay? Does this make sense? So, inches of water in the tank. Because it was a word problem, we should do a full sentence answer, yes? Okay. Number 2, I'm going to let you guys do yourself. Yep. Individual work. We want to see if you guys can do it. We've already given you the formula. You are ready. I have faith in you.
This is just one more step.
Give you guys 4 minutes. Go. Let me just start with, Miss McShannon and I went around because she didn't actually warn you guys this time. She did last class. What have I been doing the entire time? I only had 6 out of my entire side who did it. Okay? On Miss McShannon's side, she said she had 10. That's not good, guys. That's less than half. Guys, quiet down. Quiet down.
5.
Here's the big piece on this. If you mark the text, this becomes easy. It's a rectangular prism, length of 3, width of 1, height of 1.5. How much soil can it hold? There's our question. They literally gave you everything you need if you mark the text. Because again, I start with my base formula, length, width, height. They've actually given me all of those. Set a length of 3. It's at a width of 1. It's at a height of 1.5. Commutative property multiplication, I do it any order I want. So I'm just going to do 3 times 1, which is 3. Then I have a mixed number, so what do I have to do? Slam dunk. 2 times 1 is 2, plus 1 gives me 3 halves. My whole number of 3 goes 3 over 1. I don't have any reductions. 3 times 3 is 9. 1 times 2 is 2. 2 goes into 9 4 times with 1 left over. Lucas? Guys, quiet. Lucas? Good. I also must have my cubic feet. Quiet.
And because you have to have a sentence because it's a word problem.
Excellent. You guys hit everything I hoped you would hit. 4.5 cubic feet of soil in the box. That would be your full answer, guys. Yes, Miss McShann's side is doing far better than mine so far. You guys did better at marking your text. You guys pointed out the units. You guys pointed out the sentence.
It's healing and it's got those crusty scabs and it's catching on my shirt. That's the problem. It doesn't matter.
Okay.
I didn't say anything.
Guys, listen up. Okay, this next part, I'll be honest, this is what Miss McShann and I don't like about this lesson. However, almost every problem they are giving on our tests are the ones that we don't control. You're going to see these kinds of problems. So you guys have to understand how to do this. We're going to give you a visual. We're going to help you walk through this to understand what we're doing, okay? So the big part on this, determine how many of each fractional cube it takes to fill a unit cube. We have 2 parts. We need to draw the fractional cubes on the empty unit cube, and then determine the volume of each fractional unit cube. So we really have 2 parts. We need to draw the fractional cubes and determine the volume of each one. Okay? So we're going to start with the drawing to help you understand it. So if it's a half unit cube and I have a whole unit, where is my line going to be? Wyatt?
In the middle.
In the middle. So Keegan, if it's a unit high, where's my line going to be?
It's going to be also be on the top.
It will also be on the top. What about the side over here? If it's 1 high, where's my line going to be?
It's going to be.
It's a half unit. So it's going to be halfway on the side. Good. And what about, so that's also going to extend on this. And then we're also going to see it on the top. So if I actually draw that, that's what it would look like. Now, if we put it into our formula is volume equals length, width, height, correct? But I just split each side into 1/2, didn't I? So what is my length of this unit cube? So now I'm basically looking just at this 1 cube, guys. What is my length of that 1 cube? 1/2. What is my height? 1/2. What's my width? Does everybody see where those numbers are coming from?
Yes.
Okay, we start with our base formula. It's length times width times height, yes?
Yes.
So now we just put our numbers in. So we said the volume is 1/2 of a unit, the width is 1/2 a unit, and the length is 1/2 a unit. Okay? What's 1 times 1 times 1? 1. What's 2 times 2? Times 2? 1/8. They didn't give us an actual unit, so it's just units. But I did unit, 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 so that is now unit cubed. Units times units equals units cubed. That's shorthand for units times units times units. Does that make sense? Everybody, does that make sense? Okay. Now, Mr. Chan and I are going to take a minute, so we're going to pause the video, and we're going to actually demonstrate for you what this actually looks like. So, Mr. Chan's class, gather around here. My class, come right up here. Everybody stand up.
Hi.
So, you guys just got to see physically exactly how this works, right? And why that was 1/8. So let's look mathematically now with that 1/3, which we also showed you. Why is it 27? Well, I'm now breaking each side into 1/3, yes? Also on the height, yes? Also on the width. So as I go across, this is also 1/3. She's complaining about her top, not mine.
Yours looks interesting as well.
Okay, Michelangelo, come on up. So when we do this, what is my length on my new drawing? What's my length? 1/3. What's my width? What's my height? So now put those numbers into my formula. So it's now 1/3 times 1/3 times 1/3. 1 times 1 times 1 is 1. 3 times 3 is 9 times 3 is. And again, we don't have units, so we'll be units cubed. So that's why the volume of one of these cubes in the unit is 1/27th of a unit. So are you guys able to now visualize why that's happening?
Yes.
Okay? Now, what happens when we go to 1/4 unit cubes? Now, I'm doing a fourth, so I'm doing 4 into each one. This is actually one of my better ones so far, although I probably just jinxed myself. Oh, I was doing so good till that last line. Okay?
You spoke too soon.
I know. I said I just jinxed myself. But now what we've done, 1/4, 1/4, 1/4, correct? Okay? So my length is 1/4, my height is 1/4, my width is 1/4. So when I put them in my formula, 1/4 times 1/4 times 1/4. 1 times 1 times 1 is 1. 4 times 4? 16 times 4?
I thought it was 32.
Nope, 64. Storm? Good job. Now, this next one, we just gave you a huge hint on this. How do you determine the number of fractional cubes that filled each unit cube? What did we do?
It's funny because I actually asked my group that.
And none of your kids are raising their
They
hands.
knew it when they were with me.
Wow, so being near you took the answer away from them? Good, the denominator. This one we broke into 8 cubes, right? So one of them was 1/8. This one we broke into 27. So one of them was 1/27. See how it's happening? See that pattern? So the denominator determines how many cubes there are. So what was the pattern you saw as we went from 2 to 4? Did you notice a pattern? Richard? Do you have legs? You did? Okay. Go ahead. Sign out. Keegan?
The pattern is that every time the unit cube gets smaller.
Good. There's a lot more each time, right? So even as I just went from 2 to 3, I went from 8 to 27. As I went from 3 to 4, I went from 27 to 64. So it gets a lot bigger. There's a lot more cubes in a very short span. Gabby? I'm sorry? Do you have legs? Okay. Nobody sees the pattern. starting with what I started with and going to my answer, what was my pattern? What did I do? Yeah. Or what pattern did you see? Whatever you... Good. I like that. Numerator was always 1. What about the denominator?
The denominator always numbered the amount of unit cubes in each figure.
Okay. Denominator. And I'm going to add a part to that. Was the cube of the fraction and gave how many cubes there were. Good job, guys. We're down to 10 minutes.
We need to get to homework.
You can't get to homework yet. We got one more we got to do. Because this is actually a really big concept, guys. Guys, you'll catch the video later if you didn't get all the notes or get it from a friend. Guys, here's why this was important. This is what they love to do on our test questions now. So please pay very close attention to this. That means stop talking and listen.
Hush, guys.
Okay, we have a prism with dimensions 1.5 by 2 by 3 inches. We're going to pack the base of the prism with 1/2 inch cubes. So if I do 1.5 inches long, but I'm using 1/2 inch cubes, how many cubes will I use?
How many halves go into 1.5?
Gigi? 3. You can see it. 1, 2, 3, correct? So it takes 3 cubes. How many cubes do I need to pack for 2 inches? Vivian? 4. 1, 2, 3, 4. So I have 4 cubes going back. So that means how many cubes are on that bottom layer? Ava? 12. Okay? So I got 12 cubes on that bottom layer. But I also, because it's a prism, I now have that third dimension of height. My height is 3 inches. So how many cubes is it going to take to get to 3 inches? Someone didn't lock it. Cameron, 6. Okay? So this one is going to take 6 cubes.
Oh.
Sorry, she told me to move.
I'm going to end up peeking you. I can see it already.
Okay. So when we analyze this, on the base, we had 3 by 4 or 12 cubes. What's the volume of each of those? We just did the whole piece about 1/2 inch cubes is a cubic volume of 1/8, correct? If you need to check the math, it's on the previous page. Then I have 6 layers of those 12, so that's 6 12s gives me 72. Each one of those 72 cubes has a volume of 1/8 cubic inch, yes? Okay? So if I wanted to find the volume of this entire piece by figuring out the fractional unit, I now have 72 cubes inside of there, correct? Each one is 1/8 cubic inch, yes? So that means our total volume is 9 cubic inches. Because 9 times 72 times 1 over 1 times 8 gives us 72 over 8. 72 divided by 8 gives me 9. Do you see how that works? Okay? Then we use our volume formula to check. So we could use the volume formula. We would say, here's our length, here's our width, here's our height, yes? Put those into the formula. We have to slam dunk, turn it into a mixed number, or improper fraction. Technically, those are both over 1. We have 1 reduction, 2 on top and bottom. 3 times 3 is 9. 1 times 1 is 1. 9 over 1 is 9. Questions on what we just did? Yes, Jamal.
She looks like she has a question.
My brain does that sometimes. You have to just ignore me.
She catches up eventually.
It just does that.
She really gets confused when I do reductions. She's not a huge fan on those.
Really not? It's fine.
But it makes the math so much easier. I love it. Okay, guys, we are actually almost out of time. We're down to 5 minutes. So let's turn to our homework. Page 97. Tear it out. Keep quiet so I can talk.
You are not packing. You are listening to the directions.
And marking on your paper, because I'm about to give you a whole bunch of really good hints.
If I see you packing, you will be sitting with somebody at lunch and not anybody you want to, I promise.
Okay, suppose a rectangular prism has fractional edge lengths. Describe how you can determine the dimensions of the cubes that will fill with no overlays or gaps. I'll give you a hint. It starts with LCM. I need to take a look at the 3 numbers, figure out what unit is going to go into all 3 of them. Okay? Determine the number. Do I need to actually figure out the volume on this? No. They tell me it's half-inch cubes. So basically it's saying if I'm doing half-inch cubes, you can even do a drawing if you want to. How many 1/2s are going to take to get to 1 1/2? 3. That's the only number I'm going to give you. Figure out the other 2. Then you're going to multiply them all together using your volume formula to figure that out. What is the volume of a right rectangular prism that is packed with 300 1/5 foot cubes? So, key on that. You have to find the volume of a 1/5 foot cube. Then you're going to multiply that by 300. You guys should know how to find the volume of a 1/5 foot cube, right? 1/5 times 1/5 times 1/5. Okay, then you're going to multiply by 35. Don't forget to simplify. Number 3, now we calculate the volume of each prism. Does it say anything about cubes, unit cubes? No. Guys, just use the formula. Make sure you label your picture with your length, width, and height. But that one shouldn't be that hard. It's just math. Okay, it's just calculations. Same with B and C. They didn't give you anything. Start with your base formula. Length, width, and height. Label them on your picture. Should make that one super easy. Guess what? That's all you got to do, guys. Should be an easy homework assignment.
Finally.